First, thanks for inviting us over. I think the faculty and the students of UAT have done a great job in organizing this, and sincerely appreciate the invitation, and hopefully you'll learn something today. This talk might not be as entertaining as the previous one, but at least hopefully you guys will learn something new. What I'm going to discuss today is about IIoT, and what that stands for is the Industrial Internet of Things. And what I'll do is I'll go through some examples of why that is important, and how things are being implemented in the world when it comes to the IIoT space. And also I'll distinguish between two terms that are commonly used. One is IoT, which is the Internet of Things, and the other is the IIoT, which is the Industrial Internet of Things. So let me get started. This is just about our company, a short overview about us. We have about in excess of 2,000 employees worldwide. We have offices in Europe, Asia, and the US. What we focus on are those four things, which is the power, water, oil and gas, and the environment. And these are some of the areas of what we offer services in. These are some awards that we got over the couple of years, last 10 years or so. Fastest growing company. We also got the Platts Award for energy efficiency about 2 years ago. And several awards from Deloitte as well. Again, from the list of customers that we have and some of our partners, you'll get an idea that we focus mainly in the power, water, oil and gas, and the environment. And coincidentally, those four areas are becoming extremely important for the Industrial Internet of Things, or the industrial automation revolution that's going on. It's just started, actually. So let me go ahead and give you an overview of the IIoT. First, what is the Industrial Internet of Things? Think of it as an ecosystem or a platform in which sensors and devices are collecting data, and they're pushing data to a server for an analysis. And then the next step is, once you analyze the data, what do you do with the data? Because just getting the data and monitoring was yesterday's world, and today's world or tomorrow's requirement is to take action based on that data. Okay? Then, of course, the ability to control and manage assets. By the way, when I say an asset is nothing but a piece of equipment. The simplest case is the equipment could be sitting on a factory floor, completely under the right temperatures and so on. The worst cases where these devices or equipment are sitting in the field. A perfect example could be a water tank sitting out somewhere, or a gas distribution network sitting out where the temperatures are extreme. They can go from whatever, minus 40 degrees Fahrenheit to almost like 100 to 150 degrees Fahrenheit as well. So the requirements are obviously pretty stringent for that. For all these devices to work in that temperature conditions. And that's really the challenge for the IIoT, the Industrial Internet of Things. Then obviously the implementation can enhance decision-making capabilities and increase the collaboration within enterprises. A classic example of that would be where you have a piece of equipment sitting on a factory floor, and something is going wrong with it. Now, in the old days, when something is going wrong, till someone goes to that piece of equipment and looks at it, you would not know that something is going wrong with it. But with the Industrial Internet of Things, what would happen is that machine is sending out data, whatever the data is. It could be temperature, it could be vibration, it could be oil level, whatever it is, out to a system. And the system analyzes the data, and it knows exactly how to inform some other technician to go and take a look at it before it goes down. So this whole thing about data gathering, analysis, and action is what you'll see consistently as a theme in this whole presentation today. Okay? So when I say collaboration within enterprises, it could also be within the enterprise where the manufacturing guys in the group are informing the technical guys to come and take a look at the equipment and so on. Or it could be also a task order going out to a company that's outside the enterprise, where someone has to come and fix the piece of equipment. Okay? So let's Let me just give you a little bit of a difference between IoT, which is the simplest of the things, which is already happening, okay, and the IIoT. The Internet of Things is basically, the things in this case are consumer things. That could be your cell phone, it could be your wearable devices like your Fitbit or whatever it is, or it could be a GPS device, or a refrigerator sitting at home that's sending out data to a grocery store saying that you're running low on milk, for example, and things like that. That's the Internet of Things, and that's really happening, has been happening for the last 5-10 years, or if not more. Here are some images of some of the things that that you're probably used to in the Internet of Things world: TVs, toasters, watches, and all these things. So they're all, what are they doing? At the end of the day, they're sending data through the internet to a platform where data is being analyzed and some actions are being taken. Okay, these actions could be very simple in this case. On the other hand, the industrial Internet of Things is a little more complicated. For example, this could be the things here could be a machine on a factory floor, or it also could be a sensor taking data like a level of an oil tank or a water tank sitting out in the desert somewhere, for example. Okay, so obviously these things are things in the industrial Internet of Things are a little more complicated and bigger. I just brought some real examples to show you here. If you look at these things, these actually are sensors, and don't get scared. I mean, this is an actual sensor that probably can take pressure of a gas line or a water line sitting somewhere out in the open. Now, this is why is it so rugged? Because this one can withstand temperatures from -40 degrees Fahrenheit to 212 degrees Fahrenheit. So that's a huge temperature range. So the electronics in this has to work, and obviously it's a pretty rugged device. So how does this work? So what happens here is these things are all sitting out in the field. These are all sensors sitting in the field, and they're communicating to each other. For example, that one could be communicating to this, and that can hop the data onto this one here, and then from there it comes into the gateway. Okay, so these are all smart sensors that are sitting and communicating with each other. For example, if that sensor is out of range with the gateway here, then the data hops from there to there, from there to there, and then comes from here and so on. They're all pretty smart, and they can be set up in such a way that it's called a mesh technology. Okay. Now this is the gateway. At the end of the day, the data from these things. By the way, that's could be a pressure. Actually, that's a temperature sensor, and could be sensing the temperature somewhere. And this is a pressure sensor. That's a vibration sensor. So what happens is you can actually plug that sensor to any piece of equipment, and once you get any vibration data from that, that data is communicated through the gateway to our, let's say, a server that analyzes the data. Okay. So at the end of the day, all these things are sending locally through just a radio, and then from there it goes through the internet to the cloud and back into our database, for example, for analysis. And analysis is the first step, and the next is what actions can you take from the analysis. So this is a good example of some of the things in the industrial Internet of Things. One is all these could be a water tank, could be a smart factory, could be just a wind turbine sitting somewhere, or a gas distribution network. All of them have sensors. The data comes through the cloud to the database for analysis. The requirements for IIoT are much more stringent. Reliability is very important. Rock solid security. Now, just to give you an example, I think the previous speakers talked about internet security. That is as important here as well. So tampering can happen for, between when the data is communicating from that sensor to this gateway, you can have tampering of the data. So you need that security to be built in. Or when the data is communicating from this gateway to the internet to our database or to the backend server, that security is important too, because any breach in that security could throw things off, off control and so on. So what are the forces that are shaping the industrial Internet of Things? One is, of course, it's a living network of machines, data, and people, all working in tandem to kind of get data. And then, of course, the next step is the intelligence that can be increased through embedded software. Now, all these things, by the way, all these sensors can be programmed to have embedded software for taking actions or whatever is required based on what the purpose of that sensor is. And of course, now there's a lot of data coming in, okay, so transforming that massive volumes of data and getting some intelligence out of it is a big requirement for the IIoT, as you can tell. And then of course, right, the analysis and then taking actions from that is the ultimate dream. So just getting the data and monitoring is great, but what do you do with it? And how do you analyze it and how do you take smart actions real time is where the challenge is. Just to give you an idea, they're estimating by 2020 there'll be 50 billion devices that are all talking to each other and connected through the internet. I mean, your phones could be one of them. It could be sensors like this, or it could be the GPS devices and so on. If you just look at some of the data that's coming in, just one flight, data per flight is 1 terabytes worth of data is coming from a flight. Just a turbine sitting on, a blade of a turbine sitting on a windmill sends you about 500 gigs worth of data, okay? So there's huge amounts of data coming in, and I think it's going to be called big data, and you'll see a lot of data coming in. Along with data, the question is security. How secure can the data come in, and what can you do with it? This is, the ultimate goal is obviously to get one platform for all these things. These are the main drivers for IIoT, by the way. One is power, of course, generation and distribution. Oil and gas is huge. Water, wind, mining, aviation, healthcare, manufacturing, and rail. So these are the 10 things that are really going to play a big role. These industries are going to play a big role in the IIoT revolution. And I'll show you, when I say revolution, I'll show you some numbers later on. And it's quite big. Now, why do we need IIoT? Okay, I'm just giving you an example for a refinery. I don't know if you guys are familiar, but an oil refinery, it's a pretty complicated landscape of several things going on in that space. Now, avoiding shutdowns is a critical part of increasing the output. So how do you avoid a shutdown? The old-fashioned way is where you have maintenance schedules, and you know certain pieces, you can have 1,000 pieces of equipment there, and you have a schedule of saying, okay, every 6 months I'm going to do this for this, every 1 year I'm going to do something else for it. That's the old-fashioned way. With the IIoT, the idea being that I can get data from all these 1,000 pieces of equipment. I can predict when something is going to go down and take action before it goes down. Why is the output and the shutdowns critical part of that? Between 2009 and 2013, they estimated that it costs about $20 billion per year in unscheduled shutdowns in the oil refineries. Okay, that's a huge number per year. So you can estimate that what's going on in the world. Ineffective maintenance, again, is another. Now, what is an ineffective maintenance? It's doing maintenance for a piece of equipment either before its time or doing it incorrectly, where someone misdiagnosed it and did something else to the equipment instead of making an oil change or changing a motor in the piece of equipment and so on. So these things are costing a lot of money, and there's about $60 billion in operating costs per year. That's what we are spending today for ineffective maintenance. And again, these are not my numbers, but these are all Deloitte's estimates from their articles and so on. Okay. Now, what does IIoT have? They're estimating that by 2030, which is 15 years from now, it's going to add about $7.1 trillion to the US economy. That's how big it is. Today, the US economy is worth $16 to $18 trillion. So it's a huge additional increment to where we are today. To China, it's about 1.8 trillion. Germany, it's much smaller, 700 billion, and then to UK, it's about half a trillion. So these are huge numbers, and this is where there's going to be a lot of innovation, a lot of hiring, and a lot of job growth in this space as the years roll along. Let's look at what we do. So we are actually a system integrator that provides system integration services. What does a system integrator do? Takes several components like what you're seeing here, putting an end-to-end solution and going to a customer and basically giving them an end-to-end solution. We don't actually sell individual components and sensors and gateways. We put all that in a bundle and we take it to a customer for whatever requirements they might have. These are some areas, again, as I told you, that where we play in, and some of the areas of things that happen in each of those industry spaces, in oil and gas, power, water, and the environment as well. and the enterprise solutions. So let me just jump into a few examples to show you what goes on in the IoT space. Every single IoT data flow has 4 components into it. If you just keep this in mind, one is the data acquisition. So what is the data acquisition? You have sensors on all the equipment, and those sensors are getting different kind of data. For example, this could be getting the tank level, the water in the tank, and so on. This could be measuring vibration in that. This could be measuring power output, and this one, sensors here could be measuring leakage or flows in those pipelines and so on. Okay. By the way, just to give you an idea, this is a product made by Digi, and this is a sensor that can be sitting on an oil tank somewhere in the desert. And what it can do is it's got a cellular card in it, and it can sense data and send it out to your database, for example, for analysis and so on. It's all it needs is a SIM card. Battery lasts for about 2-3 years, and it just does its thing as and when you want it. It could be every day, every hour, whatever it is. Okay, so it's, as you can tell, it's a pretty simple system for measuring whether water. It's a tank level monitor, either for water or oil or anything else in the field. So going into the next step, right? The first step is data acquisition. The next is, now I want to let you know, keep in mind, all this has to be done securely. Okay, so security is really important in this space, and data coming in from there to the gateway. Like I told you, any tampering of data from there to there could lead to a lot of breaches and a lot of things going off track from that standpoint. Once it comes to the gateway, which is this big box here, then data through the internet goes into our data analysis to our servers. And then after that, the final step is taking the control and actions. The real promise is in closing the data loop and using that information to trigger action. That's really the important thing, okay? Just getting the data and it's sitting there is not going to do anything. How do you write smart software and smart algorithms that can utilize the data to take action? And actions can be anything. It could be shutting down a pipeline here, shutting down this wind turbine, or sending a crew to go and fix the oil leak, whatever it is, whatever the actions are based on the data that you're getting. Another example, by the way, in fact, just using these sensors here, I put together a simple example where, let's say this is a water pumping station. You have water production there. You have 2 sensors here. One could be the pressure sensor, and one could be the, can't see the colors, but it could be even a level sensor, for example. Then you have the treatment and storage here. You have different sensors. You have the storage tanks here. All the data, just like how I showed here, comes into this gateway and then comes to the server for analysis. Okay. Let's take a look at what's going on in the world today and why there's a need for IoT. In today's world, the present mode of operation for monitoring is use of landlines. Basically, you can sit here. I mean, this is your server here. You can sit there, through telemetry, you can make a call to some of these equipment here and get data, okay, through a landline, for example. Now, they're expensive, and of course, most of the carriers are stopping and supporting landlines. In the future, you'll probably not even have landlines anymore. You'll just have cell towers and cell lines going forward. So data collection, again, is expensive. So what happens in this world is a guy goes there, takes data, comes back, drives back, and then dumps it into the server for analysis. That's how things are being done today. Now, going forward, what can happen is the same data goes through a cellular network and then can come to your server for analysis. So it has to be secure. Then you can do real-time analysis based on the data, and you can take actions and do the reporting as well. Benefits of the monitoring obviously is integration with, you can actually put these sensors on existing equipment. That's the real advantage of some of these things that are coming. You don't want to go and make sensors that don't work with old equipment. Okay, then you're losing value of what's out there. Then, of course, safety issues is a big thing. You don't have any personnel on site. Then the other one is that the repairs are faster. Why? Because data acquisition is in real time. And if you can do the analysis and then actions in real time, then obviously things are going to happen much faster. And at the end of the day, it's all about cost savings and improved efficiency. Remote water tanks, again, the challenges are, this is another example. You have tanks here. Now, in a typical application, what happens is there's chlorine that needs to be treated, the water needs to be treated with chlorine. And so in the old days, what used to happen is that you have a schedule of how much chlorine needs to be added to the water tanks. Now, you just add it based on known conditions at that time. Now, the problem is in such a case is that things might not be accurate, or you might either add more or less of the chemical, and you're not really doing it based on real-time data in this. Going forward, what can happen is you can have sensors sitting in here that are actually measuring the chlorine content, and you can dispense the chlorine based on what's going on real-time in the water tank, for example. Okay, so you can see how real-time data acquisition and then the actions will help some of these things. Again, the benefits for all this is ease of operation, then the durability in hazardous environments. You can reduce any leaks, you can reduce any over-chlorination of the water and so on. And then the increased control of chlorine injection, that's important, because if you can really monitor this real time and get data, then you can obviously see how you can save any over chlorination and so on. Another example is gas distribution network. You have the gas distribution here, and in the old days, again, it was a dial-up network where things were monitored, and then actions were taken based on whatever data is coming in and so on. A lot of safety issues, and a lot of leakage in the valves and so on. The power loss was could be pretty high compared to getting the data real time. Now the IoT solution is, again, just like how we have here, sensors, cellular network, data communication to the server, and then action back again here. Okay. Benefits again are huge. Let me just go through some of the numbers. Gas distribution companies spent wasted close to about $183 billion worth last year, or in 2011 rather, by releasing unintended amount of natural gas into the atmosphere. Okay, that's huge. Now, if you can actually measure that real time, you can actually take action, and you can bring those numbers down significantly. Let me just go on here. Wellhead monitoring, again, is monitoring of a wellhead for an oil tank, for example. Same thing. The challenges are, if you do it manually, it's kind of cumbersome. It's not safe, and there's things that could happen which are not under your control. On the other hand, with an IoT solution, you can get data, sensing data through a cellular network, and you can take action real time. The benefits, again, could be, let me just show you some of the numbers here if I have some. But again, at the end of the day, it's reduced costs and more automation and more control. Yeah, so basically what we are saying here is there's about annual losses of about 10 billion due to fuel leaks that are happening in these gas pipelines and so on without being monitored real time. These are all huge numbers, by the way. I mean, these numbers are all staggering if you find out what's going on. Now that we have some of these smart sensors and all, there's a huge need for automating all this data collection and then reducing those losses. Water pump station, again, another example. Challenges of doing it manually, the old-fashioned way. Then the IoT solution is remote sensing, data acquisition again, and then taking action. Savings of about 30 million in a 2.5 million gallon tank. So that's, I mean, those are all, again, you can just take how many tanks are there in the world and what the numbers are. You can multiply that. These are all big numbers. A single pump failure can cost anywhere between $100,000 to $300,000 a day in lost production. So if I can identify that ahead of time, and if I can take action, I think that's where there's value in this whole thing. So what are the opportunities here? Key target areas are interoperability. Again, what we are saying here is hardware and software solutions that can work across various platforms. This is really critical. For example, these things today are working on, let's say, a Windows platform or a Linux platform. how can I take this and then put it on a different platform and make it work still? So whoever is going to do some innovation in this has to think about that, of how a product can be a plug and play for if I move across various platforms. Okay. Data security obviously is very important, both during data acquisition and the communication piece as well. If instantly there's not much work still being done in data acquisition and security in that space, because it's pretty difficult to encrypt data going out from a sensor over a radio bandwidth to the gateway, and there's a lot of challenges. It's very easy to transmit data from a sensor to that. Question is there any potential of tampering with that? And if someone were to change the data before it reaches the gateway, you could be shutting off valves in the wrong places, or you could be over coordinating tanks without even knowing. So data security in that space is very important. Data analytics, as I said, again, how do you make a generic and a configurable software that I can take data, any data, analyze it, and take action? Okay, there are very few companies again that have got a solution in this space, but that's going to be a big challenge going into the future. It's very easy to customize any software for one particular application, but that's going to have limited use. So the question is, how do you take that, make something that's generic, and I can put it across different applications? And then closing the data loop and using that information to trigger actions is really, really the ultimate benefit from all this IIoT platforms. Smart connected objects offer tremendous opportunities for value creation and capture, but they can also create tremendous risk, demanding new strategies for value protection. Again, this is about security and how do you prevent that. So along with ease comes issues of cyber attacks and security issues as well. Okay, in terms of for this crowd here, what are the opportunities in this space? Degrees in electrical engineering, network security, computer science, and business and marketing. Understanding of distributed systems is important for jobs in this space. Peer-to-peer networks and computer networking. Experience with embedded software is going to be useful. Data security and analytics. I think this is probably one I would say is probably the most important in this space. And of course, if you want to go into the marketing side, on the business side, computer trends and needs of customers is important as well. Again, in closing, IIT has the potential to transform industrial operations and provide greater competitive advantages for companies. And I think the whole race has just started. The world is transforming from IoT to IIoT, and if you guys have an interest in that space, I think this is a good start. So, any questions? Sorry. Yeah, sorry. Right, so all these devices, by the way, you can program them to push data on your schedule, whether it's every hour or every minute and so on. And there's usually a data log, and I think you bring up a good point. So for example, smart meters are in the same example. A smart meter is supposed to give you data, say, every 15 minutes. And if data didn't come in for that 15-minute slot, then there are algorithms. In fact, we have written algorithms ourselves called data validation and verification. And what happens is you validate the next bunch of data, and you estimate. It's called data validation, verification, and estimation. You estimate what that value would be based on two other points, and you make some smart decisions based on that. So it's, if data is continuous, it's good, but absolutely it's bound to happen in a practical world where some data points would be missing. And so there are algorithms that will give you an estimated value for that slot and move on. Yeah. Anything else? Sure, sorry.
What kind of advice do you have for students here who are wanting to pursue a career like yours?
Career like mine, or?
Yeah.
Okay.
Want to be you one day.
Oh boy. Passion, hard work, and confidence in yourself. Again, I think knowledge is really what you want to drive. I mean, if you can get knowledge in whatever space and you'll get a lot of respect just from the knowledge. And again, it's just going in the area that you enjoy. Don't go into an area that you don't enjoy just because 10 other guys did that. Go into something, follow your dream in something that you really like. It might not be popular today, but as long as you enjoy it, do it, and that's the way to go. Yeah.
So you mentioned that one of the risks considered is manipulation or data forgery.
Sure.
What about just denial of service, like the jammer, at least jammer database? What would be, what's like the current method to handle that?
So the good news is, let's talk about it, data jamming, for example, right? The good news is, like, I think she asked a question, right? You're expecting data to come in certain intervals. So if it doesn't happen, like for whatever data jamming and so on, then you can write an algorithm and set off alerts just for that alone, okay? So remember, artificial intelligence is going to jump in very quick into this, looking at patterns of how things are happening, and systems can start looking at previous patterns to fix future events and so on. So an example is, if I know data is supposed to come from that sensor every 1 minute, and for the last 2 hours it's not coming, so either someone has bypassed the data for me or has jammed it, so alerts can go off to a technician to go back and take a look at it, and so on. So yes.
I was just wondering, how do you get new clients?
How do we get new clients? So that's a tough question. So basically, clients look at us for our knowledge in the space. A good example is, by the way, these products are from Emerson, and Emerson is a large company, as you guys know. Now, Emerson sells these as components, okay? And they just have a data book of all these products that they sell. When we go to client, we go with what's called an integrated solution or a solution bundle. We tell them that, you know what, for your application, we can put an end-to-end solution for you, whether it's with our product or with partner solutions as well. So the way we go to clients is our knowledge in that space, and then giving them an end-to-end solution, as opposed to just selling the sensors by themselves. Today, companies are looking for a complete solution package as opposed to just one piece in the value chain, for example. So, thanks. Anything else? Sorry, go ahead.
Something kind of topical, actually. So how would you imagine the industrial Internet of Things playing out right now with Patricia and the hurricane that's hitting the coast of Mexico? That sounds really fascinating to me to have. You guys are not only talking about monitoring. We've had monitoring for how many years?
Exactly, yeah.
Take a look at it.
Right.
How do you see it playing out? Maybe not now, this time, but in the future for like natural disasters.
Well, so again, right, as long as you have sensors to sense, so the sensing world has to become smarter. How do you build smart sensors to sense things that we are not aware of, or to foresee things before they happen? And I think that's, by the way, it's funny you mentioned that. Now they're talking about sensors for even predicting drought and so on. How do you tackle that problem before it happens, and so that people are better prepared and so on? So I think as far as the IoT world goes, sensors are going to become smarter, and today, quite honestly, there are only 10 or 8 sensors out there today. One is a water sensor, one is a pressure sensor, one is a temperature sensor. I mean, these are all standard things, right? When people start becoming smarter and start looking at other sensing capabilities to figure out things, that might come in the future and start taking action, I think that's when things will start shaping up in that space. Yeah.
This may be more theoretical.
Sure.
Most of the products you have up there are obviously newer. How would you embed that into legacy models that's already implemented into the areas that the oil rigs, the natural gas pumps, all these different solutions? But how would you implement like 4th, 5th generation technology in the things that are legacy? Because things that are legacy, such as like hubs,
Sure.
they're already gone. They're replaced with switches, routers, but you have to completely change all that. Wouldn't that cost effectiveness be like less? Because you have to replace all the legacy technology of the entire foundry.
Right. I think that's the beauty of this, by the way. So one of the requirements for IoT is make solutions, and I'll give you some examples with this, but make solutions that will sit on existing equipment. There's no need to change. I'll give you a good example. Let's say that thing there, it's a vibration sensor there, okay? So I don't have to go and change the equipment that I'm sensing the vibration from. All I do is get that there, and it's got magnetic sensors that sit on it, and it can tell me how much vibration I'm getting in that. Most of the sensors, that's one of the big requirements. That's a great question. One of the big requirements today in the IoT space is that whatever you do, it has to work with existing equipment. If you're trying to replace the existing equipment, then you have another challenge to deal with down the road. Yeah.
So the challenge wouldn't be, can I replace the legacy equipment? It would be, how can I make newer technology work with legacy?
Absolutely, that's the number one requirement, to make new technology work with existing equipment, because otherwise it's very expensive and it's not impractical to do that. Slowly things will start improving on that equipment where there's a match between new technology and the legacy equipment. But now the assumption is that all that equipment is going to stay there as it is. Oil rigs are not going to change, refineries are not going to change, the factory equipment is not going to change. How do you make the sensors to work with that? And that's a huge requirement. And it's happening. If you go back, and this, by the way, these are the real worst case scenarios I'm showing you here, because these are to sustain extreme temperatures. But if you go back and look at any Intel manufacturing facility and so on, all the factory equipment that is there is all being automated in a controlled environment and with existing equipment. So. Anything else? Any other questions? Any comments? Go ahead.
What are you doing for security? What are you doing now? Because it's a very scary thought to implement this alongside the internet. Because anything can happen. You never know what's out there.
Sure.
Zero-day attacks. Do you implement this to customers using out-of-band communication or something that no one can get to? Or ensure that
Yeah. So a couple of questions, by the way. One is, the first one is, all these things are working with existing band, I think this is a 2.4 gigahertz communication, which, so today, to be honest with you, I don't think there's any security built between the sensors to the gateway. From the gateway, of course, there are all the secure protocols and everything else that you can use, okay? So I think that is being addressed as we speak. Now, in terms of confidence, right, I don't know if you know, today, when you take a flight, I don't know if you know, 80–90% of the time the onboard computer is doing all the flying for the pilots. So that's happening today. Likewise, if you look at the Google car and so on. So slowly as things come in, I think the confidence of machines to control things for you will be accepted and adopted. So I think that's going to happen over time. But are we doing anything different today? There isn't a solution today to encrypt data from these remote sensors as yet, and that's going to happen soon. Yeah.
Thank you so much.
Anything else? Okay, thanks.